Hello and a warm welcome. This is Mr. T. As always, it's a joy to have you aboard. Thank you for tuning in. I hope I find you well. This is a continuation to our video edition on sequences and series, and in today's section, we're going to be looking at sum to infinity, which is a subsection on geometric series or geometric sequence. Important for you to watch the videos on a geometric sequence together with the one on a geometric series. Without any waste of time, let's go straight to the first question. Consider the geometric series 45 plus 15 plus 5 plus and so on. So the first question is saying, does this series converge or diverge? So we need to find our common ratio R, T2 over T1, which is the same thing as 15 over 45. Simplified, it gives us a third. So our R is equals to 1 over 3. Since our R is equals to 1 over 3, it follows that it lies between the interval -1 and 1. And therefore, we can make a conclusion that the series indeed does converge. So it does converge. Very important. The second question, part B. Determine the sum to infinity. To determine the sum to infinity, we're going to use the sum to infinity is equals to A over 1 minus R. Then we're going to substitute our A value and our R value respectively. So we're going to get 45 for our A over 1 minus a third for our R. Then simplifying that, we're going to get the sum to infinity of 67,5. We move on. You are given those three terms forming the first three terms of a geometric sequence. The first question is saying, for which value or values of x is the sequence convergent? So it is indeed convergent. That means your R has to lie between -1 and +1. So we're going to get our R as R is equals to x minus 2 to the power 2 over 4 divided by x minus 2. Then simplifying that, we get our R to be x minus 2 over 4, representing our R. Then we're going to insert our R in the interval -1 less than R less than 1, getting -1 less than x minus 2 over 4 less than 1. Simplifying that, multiplying by 4 on both sides, we get -4 is less than x less than 2 less than 4. Then again, moving the -2 from the center to the left and to the right, we're going to get -2 less than x less than 6, representing the interval for which the x values will make that series convergent. The last question. Determine the sum to infinity if x is equals to 1. So we're going to start off by rewriting the three terms in algebraic form as they were given. Then after doing that, we're going to substitute our 1 in place of x to get 1 minus 2, and we get 1 minus 2 to the power 2 over 4 and 1 minus 2 to the power 3 over 16. Simplifying those values, we get -1, we get -1/4, we get -1 over 16, representing our three terms. From there on, we need to find our common ratio. We're going to say 1/4 over -1, implying that our R is -1/4. After getting our R value, we're going to say sum to infinity is equals to -1 over 1 minus 1/4. Important. Therefore, we simplify that, we get our sum to infinity being equal to -0.8. I hope you enjoyed. Keep well and watch the next videos.